KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hi students, good morning to everyone. In this video session, I would like to continue about our 12th standard chapter regarding Neet issues, that is human reproduction. Already in the previous videos, that human reproduction, some of the topics already covered. In this video, fertilization and after fertilization, implantation, how it will be happen. In between of the fertilization and implantation, these two events, what are the developmental stages occurs in the zygote, because fertilization process, fusion of male and female gamete, then finally it will form the diploid zygote. That diploid zygote want to implanted in the uterus. Fertilization occurs in fallopian tube, ampullary isthmus junction. One more time I will revise here. So here, in between of the fertilization and implantation, that these two events, what is the development is happened in the zygote. That developmental stages we will discuss in this video. Let me start today video session. Sinana fertilization. Fertilization will occur at ampullary isthmus junction. Ampullary isthmus junction is a parts of the fallopian tube. Fallopian tube containing the three infundibulum, that is the first part. That part only having a finger-like projections, that fimbrious. Fimbrious only collected ova after releasing. That ova in the stage of secondary oocyte. Kadananna. So that released ova by the ovulation, ova is receiving by the fimbrious. That fimbrious will give to the ova to infundibulum, then ampullary, then ampullary after isthmus. So when the ova is reached at the place of the joint place of the ampullary and isthmus places, okay, it will settle in that place. Okay, then by the coitus, male and female organisms, male and female gender persons are meeting to each other, and meeting time male person release the semen into the female genital tract. That process is a coitus. That coitus time ejaculation. By the ejaculation, semen is released into the female genital opening. So then onwards, that sperm cell will move to the up to fallopian tube by the capacitation, because of when the sperm cell present in the male reproductive tract, it is not much activeness. So when it is by the ejaculation process, when it is enter the female genital tract, it attains mobility. Okay, it attains ability to the move fast to towards of ova for the purpose of fertilization. So by that process, it ready to fertile. That process we call as a capacitation. The increasing of ability of sperm cell, that is called capacitation. Okay, whatever it is. So here, by the small movement of fallopian tube, that are peristaltic movement, the released ova is placed at the ampullary isthmus junction. That process we call as a conception. Okay, now the total gametes are present in the fallopian tube. Total means here male and female gamete. So that male and female gametes, by the several enzyme actions, it following fertilization event. That enzymes are hyaluronidase enzyme, hyaluronic acid enzyme, acrosin. These enzymes are released by the a cap-like structure present at top of the sperm cell, that is a acrosome. Correct na? that acrosome releasing these fertilized enzymes. So here I mentioned. So second point come ova, when you at the time of the fertilization, these ova surrounded by the still 3 layers. That 3 layers, one is zona pellucida, remember kadana? Adikaparam outside corona radiata, correct na? Corona radiata veliya side, outer side, still some of the granulosa layers are there. That granulosa layers we call as a cumulus layers, because the layer of the layer surrounded by these ova in the granulosa cells, that we call it cumulus orifice. Diagrammatic representation time I drawn that cumulus orifice. So here which of the cumulus layers are present around the ova, that we call as a cumulus layers. Totally 3 layers. Within inside of these 3 layers, the ovum or ova consisting with the 2 cell condition. One is first polar body also present. First polar body present at the place of pre-vitellary space, and then adiki ulla ovum is there. That ovum fertile by the sperm cell. Okay, one single sperm cell. Millions of sperm cells are ready to attack on the one single ovum, but only one sperm cell will enter the inside of the ovum. So ovum is fertile by the only one single sperm. Such a type of fertilization we call as a monospermy. Monospermy. Okay, it is controlling by the some of enzymes. Zona pellucida is there. That zona pellucida become a tight. Okay, after one sperm cell enter inside of ova. So such is a process a monospermy. Okay, then that fertilization time, the ova is present at the stage of meiosis to metaphase. Still not at cell division, not yet completed. So when the sperm cell enter the inside of ovum, on the time low, these ova will get motivated by the sperm cell. It complete the meiosis 2. By the completion of the meiosis 2, totally 4 cell stage will be happen. Sir, how 4 cell stage will happen means meiosis 2 followed by the ova and secondary polar body. Correct now? By the meiosis 2, by the polar body, 2 cell will produce. By the ovum or secondary oocyte, completed these meiosis 2, polar body onwards 2 cell, ovum onwards 1 micro cell and 1 macro cell. Okay, macro cell act as a real ovum, micro cell also one more polar body. So totally 3 polar bodies with 1 female gamete. So here by that monospermy activity, ova stage will be activated from the meiosis to metaphase. Totally it completed. Okay, then now male gamete fusion with female gamete, the process we call as a fertilization, no doubt at all. It is also called as another name, sir, that is a syngamy. Syngamy means singing, sing means mixing, gamy means a gamete mixing to each other, that is a syngamy. Or syngamy also called as a amphimixis. Amphimixis means, amphi means 2, correct na? Mixis means 2 things are mixing to each other. So amphimixes. So shortcutly direct definition, fusion of male gametes. Fusion of gametes, male and female gametes. That is a syngamy or amphimixis. But when it is mixing to each other, it means here gametes are mixing to each other. Male gamete having the one haploid nucleus, correct now? And then female gamete also having the one haploid nucleus. The both haploid nucleus mixing to each other or combined to each other, that process we call as a synkaryon. Karyon means nucleus. Prokaryote, eukaryotes. In the time, karyon indicates nucleus. So synkaryon means, syn means already here, syngamy time already I discussed. Mixing. So which are mixing here? Nucleus are mixing. Okay. So after gametes mixing to each other, they are continue mixing of their genetical material. Karyon means nucleus. Nucleus is nothing but genetical material only now. So that genetical material mixing to each other, that process we call as a synkaryon. Nothing but 2 haploid nucleus mixing to each other to form the diploid nucleus, that's all. So that only here definition mode I have explained. Nucleus union to formation of zygotic nucleus. Zygotic nucleus ki and then gamete nucleus ki vyathyasam enna, gamete nucleus is a haploid condition, 2 nucleus irukku, and then zygotic nucleus, it is a diploid condition formed by the fusion of the male and female gamete nucleus. So male and female gametes fusion means that will form the zygote kada. So zygotic nucleus formation we call as a synkaryon. Okay va. Then now when the synkaryon time only we want to discuss, we explained about the sex determination. Here the newborn baby sex determination based on the these gamete mixing of gametes. Okay, because of already in the last video I explained, here in the human reproduction male person is a heterogametic. Why male person is a heterogametic? In the last one pair of sexual chromosomes XY condition. So by the meiosis process it will form the 2 haploid condition cells. That 2 haploid condition cells are dissimilar, not similar. One cell containing with the Y chromosome, one cell containing with the X chromosome. So based on that what type of chromosome containing sperm cell is fertile the ova, based on that sex determination will occur. So that's why simple statement, sex determination by the heterogametic male parent. Heterogametic male parent. So in the human beings sex determination depends upon the male gender, not depends upon the female gender. Okay, so male gender onwards sperm cells, especially male gender onwards what sperm cell is fertile, that ova. So here male act as a heterogametic parent. Okay, this is the fertilization process. Already the previously some of the extra information we discussed in previous videos. Now in this video I will continue after fertilization process. Here fertilization completed, in the place of the ampullary isthmus place, pointer place parangana ampullary isthmus place. Now after fertilization it formed diploid zygotic that containing with a zygotic nucleus. Now what are the changes that happens inside of that zygote, that we want to follow. So after fertilization what are the changes that happens in the zygote, that totally we will study under the embryonic development. Embryonic development. Okay, I wrote in the different font. So here embryonic development start with the cleavages. Sir, what is a cleavage? Cleavage is nothing but a normal cell division. Normal cell division, mitotic division, not meiosis division. Okay, so a normal cell division, if it is occurs in the zygote, that cleavages we call as a, that cell divisions we call as a specific name, that is a cleavage. So we know basic rule, when the cell is involving in the cell division, it is multiply their number. So according to that rule, in the cleavages, cell division in the zygote, in the cell division in the form of mitotic division, they are rapidly increasing their number. Okay, see that increasing by the increasing of their number in the zygotic cells, that will form the one ball like structure that we call as a morula. Morula, diagrammatic representation side I will explain. Morula. Okay, here several divisions we want to complete from the changing of the zygote to morula. Then after morula it will become a blastula. Blastula after blastocyst. These blastocyst stays only to start implantation process. To start implantation, I will continue. These blastocyst will become a gastrula. These gastrula nothing but 3 germinal condition, 3 germinal layer condition only we called gastrula. What are the 3 germinal layers? What are that 3 germinal layers? One is ecto, meso, endo. Ecto, meso and endo. 3 germinal layer condition we called gastrula. Whether you remembered or not, in the previous videos I said one statement. Nana here in the 11th standard. Okay, in the 11th standard our body parts are everything is origin or derived from the ecto, meso and endoderm. Correct kada? So here by the involvement of the ecto, meso, endoderm, our body parts formation we call as a organogenesis. Organogenesis. Then adikaparam organo fully developed fetus, organogenesis formed fetus in the 9 months after gestation period, after it will be delivered by the pasteurization process. Okay, we will continue today video in this cleavages time. Here human being express embryonic development having the cleavages step. That cleavages are holoblastic cleavage. Holoblastic cleavage anna meaning enna, the total zygote involving in the cell division. Okay, there is no any remains part of not yet involving in the cell division. So there is no any exception part in the cell division. So total zygotic parts or everything will be involving in the cell division. So that's why we called holoblastic. So total all the zygote involving, whole means a total. By the division it will form the blastomeres. Cells we call the blastomeres. So that's why we kept name as a holoblastic. Okay, these cleavages of embryo that we called as a holoblastic. Okay, now another information here, why human beings are expressing holoblastic cleavage, reason venum. Here human being egg is a microlecital condition. Microlecital condition anna, there is no much quantity of white yolk in the egg. White yolk in the egg. What I am conveying, are you following? See, for imaginationary view I will be recall one thing, egg, chick egg. When you broke down that chick egg, here two type of yolks are there, or two type of liquid things we find it inside of the egg. One is a white, another one is a yellow yolk. Here real embryo, what it is a real embryo? Yellow yolk only will become a real embryo. But other than yellow yolk, something white yolk also is there. That white yolk act as a nutrient substances for the developing baby, correct na, by hatching time. Okay, in the hatching time. So here like that yellow yolk, okay, yellow yolk embryo, around the yellow yolk white yolk is there na, that white yolk is very less in the human being, very less. So that's why such a condition eggs we call as a, ovas we call as a microlecital condition, less yolk. Which yolk? White yolk. Okay, because of here the developing baby will get nutrition from the mother with the help of the umbilical cord and placenta. But if you take any other organisms, I mean what I explained now, chick egg does not have direct contact with the mother. After laying the egg, chick of hen is hatching that eggs. So up to 21 days, within the 21 days of time duration, the developing baby, chick baby want to take nutrition. So that's why it needs something additional support, additional nutrition. So that's why these things, lecidal eggs are necessary. But human being egg is a microlecital condition. So very less white yolk. Our human being cleavages we called as a radial cleavage. Radial cleavage anna ungalku theriyum, adu enna meaning, if cleavage cell division or cell division time, it will pass on through the central point of the zygote and each and every division, such a type of division we called as a radial. Okay, radial, nothing but just if you are cutting of apple in the several pieces. Okay, first 4 parts, if you want to cut 4 parts means first one horizontal, another horizontal, again. So several 360 angles onwards, if you cut that apple, it will pass on through the central axis, correct na, central point. Okay, must be pass. That type of division we called as a radial division. Okay, so radial cleavages and indeterminate cleavage, second point nanna. Indeterminate, that means we cannot count how many times are cleavage, how many times are involving in cell division. So it is depends upon the several, but we can't measure it. Okay, indeterminate. and then unequal. By the cell division, it produces the two type of cells. One is a bigger size, one is a small size. So that's why basing on these features, human being cleavages we call the holoblastic and radial cleavage, and then indeterminate cleavage and unequal cleavages. Remember it, no? Major important question. Maybe there is a chance matching based question. So here by the cleavages, zygote will form the several cells. That cells we call as a blastomeres. In the arrow mark paranga. Zygote by the cleavages it produces several cells. That cells all are we call as a blastomeres. Okay, va? So here your conventional understanding wise, this is a zygote. Zygote undergoing one cell division, two cells are formed. These two cells are again following by the one more mitotic division, that four cells. Four cells are following by the one more cell division, 8 cells. 8 cells are continue their cell division, that will produce a 16 cell stage. Okay, here either 8 or 16. In that condition of structure we called as a morula. Morula. Okay, your pronunciation morula. Here these morula still it is present in the fallopian tube. Fertilization also occurred in the isthmus ampullary region. Now ampullary isthmus region. Now these blastula morula stage also still present in the fallopian tube. So that morula stage appearance like solid mass cells. Solid mass cells. Just like a one flower. Okay, cluster flower like. So that is a solid mass cells are we can find in the morula stage. Still in this condition also, these morula stage is surrounded by the one layer that we call the zona pellucida. I think so from the beginning onwards, the primary oocyte onwards, the zona pellucida is continue of their in the developmental stage. Okay, so primary oocyte present in the ovary condition, in the inside of the ovary. So still it is a continue. So zona pellucida. Now these cells by the cleavages, what are the cells are producing by the cleavage in the zygote? Those cells we call the blastomeres. Already I said blastomeres are two type of cells. So based on their size, small cells and large cells. Large cells are presented peripheral sides and adjacent side, and small cells are arranged into the inside. Okay, so if you take any one ball-like structure, that ball-like structure cells containing with two type of cells, adjacent side larger cells, outer cells, and inner side small cells. Okay, inner cells we call the inner cell mass. Inner cell mass. Pointer place. I am discussing about the blastomeres. Blastomeres are two types basing on their size. If it is small size, it is presence inside of these cleavages. I mean that zygotic condition. And then larger side cells are covered that are arranged into the peripheral side. So that is that which are the cells are covered the total zygotic developmental stage that we that cells large in size. That cells we call as a trophoblast. What it is? Trophoblast. And then small cells, its presence inside of the trophoblast cells, that we call as a inner cell mass. That inner cell mass also called as a embryonic proper. By hearing of these word itself, you can guess one thing. Here zygotic cell onwards producing these, it want to develop into the embryo. Embryo is nothing but a baby, correct na? So this is the real cells involving in the formation of the embryo. So that's why embryonic proper, a proper cells to form the embryo. So that's why we called inner cell mass is as a embryonic proper. But that embryonic proper is surrounded by the flatted outer large cells that we called as a trophoblast. Okay, va? See, these steps are this structure is followed by these 16 cells. See, these 16 cells again here I mentioned these 16 cells, one more cell division that form the 32 cell stage. That 32 cell stage we called as a blastula. Okay, this is a stage. Okay, that just don't think
cell counting. Simply it is a ball like, outer side flattened cells, inner side more number of cells, okay, inner cell mass. Now these inner cell mass will attaching to the one side of the tophoblast. Okay, why it is happens? See here, gradually these blastula increasing their size, cell size will increase. Along with the cell size increase, it suck the something fluid from the endometrium, okay, or in the surrounding places, not at endometrium, of course. So here, by the filling of the something fluid inside of these blastula, some of the cavity will form inside of the blastula. Based on that accumulation of the something fluid inside of the blastula, these inner cell mass will move into the one place, there, one side. So by the allowing of the something water fluid inside of the blastula, these cells here, do you understand the differentiation between these? Here there is no cavity, here cavities appears. So by the cavity accumulation of the water, so these inner cell mass will be moved towards of one corner, okay. So finally it modified like this stage, okay. When these developmental stage containing with the cavity, that stage we call as a blastocyst, okay. So now these blastocyst want to ready to implantation, okay, okay. So finally here these diagram paranga, next last diagram, come to the, here already I said, if you seen these diagram, here one side, the outer side is a covering with one layer, that layer only we called zona pellucida, blue color I mentioned. ಅದಕ್ಕೆ ಉಳ್ಳ tophoblast cells are there, tophoblast, flattened and large cells. By the accumulation, by the presence of these cavity, the inner cell mass are moving to the one side, one corner. So some of the place of the tophoblast is giving the chance to attaching of these inner cell mass are embryonic proper. Now inga paringa, two statements I will say. Which side embryonic proper is attaching to the tophoblast cells, such side, that side we call the animal pole or embryonic pole, because of that will be modified into the embryo. So opposite side of the animal pole or embryonic pole, abembryonic pole in the last, abembryonic. Remaining parts are everything you know, okay. This is the tophoblast cells, okay, this is the tophoblast cells and it is the inner cell mass. Now I will announce one of the important cells, inner cell mass irukna. In the inner cell mass attaching with the tophoblast on one side of blastocyst. So which of the cells are allowing to or attaching the inner cell mass, or inner cell mass attaching to the which tophoblast cells, those cells we call them cells of robber, and cells of robber cells or cells of robber. So what do you understand here? This is the body cavity. By the presence of the body cavity, inner cell mass will attaching to the one side of tophoblast cells. That tophoblast cells were modified into the cells of robber, okay. I forgot to explain one thing here. By the accumulation of something fluid quantity, that body cavity is forming now. That body cavity, first body cavity, these first body cavity, okay, we called as a segmental cavity or else primary body cavity. This is the time to recall. In the 11th standard you studied pseudocoelomatic organisms. What is the meaning of pseudocoelomatic? If the cavity is present in the organism, that organism means adult or fully developed organism, that coelom or body cavity not yet formed by the mesoderm, just embryonic developmental cavity. Embryonic developmental cavity means just now we discussed here. these cavity, segmented cavity or primary body cavity or blastocystic cavity, blastocele, we called simple word blastocele. Blastocele, still it is present in the adult one. That type of body cavity we call as a pseudocoelom, pseudo body cavity. It is a body cavity, but it is not real body cavity. Real body cavity is origin from the mesoderm. Okay. So next continuation implantation I will be teach in the next video. Okay. So 30 minutes are completed. So in this video we completed about the fertilization and cleavages process. Okay. Here at the completion of development at the stage of the blastocyst, now blastocyst is enter into the uterus. Enter into the uterus. For what purpose? It want to implant. Correct na? So when the blastocyst is reach the uterus, there is a interaction between the uterus inner wall endometrium irukna with the outer side of these layer, these blastocyst. Trophoblast is there now. So a connection or attachment of the trophoblast cells with the uterus endometrium, that we call the implantation. That we will discuss in the continuation video. Okay Nana? Any changes you required means inform to proper teachers. We will be rectify that technical problems or manual problems also. Okay. Thank you.